Here we have two cans, and we have them separate here, step 1. Step 2, we're going to bring them together, and then step 3, we're going to bring them back apart. Let's do step 1. To represent both cans, I'm going to make a box. Now, the cans start off being neutral. I'm going to put 3 pluses, put 6 pluses, and 6 minuses in each one. 6 pluses. I'm going to erase some of these. So if you're writing at home, use a pencil. Now, this can B is neutral, so we'll keep it like this. But can A, it's positive. So I'm going to actually erase 2 of these. I'm going to make those charges just so we can see them. I'm going to make these red. So these two are not neutral. Can A is positive. And can B is neutral. Now, in the next step, what we're going to do, in step 2, we're going to bring the cans together and see what happens. So here we're going to take can B, and we are going to move it into can A. And as soon as they touch, because they're conductors, and here's really the trick, they become one. So now it's like we had 2 cans, now we really have 1 can. And this one is positive, this one's neutral, but this positive is going to be offset by some of these electrons over here because they're going to try to disperse the charge across the entire piece of real estate. Look at all this extra area they have to disperse these 2 charges, right? So this electron, they're going to try to get this positive way as far away as possible. And so I'm going to erase this one, and it's going to move because the proton cannot move, the positive cannot move. It's going to move to neutralize this one. And this is now left positive. And this is now neutral. We had 2 positives. We brought the cans together, and we still have 2 positives. To make it clear, we have this one, and we have this one. The positives didn't move. The negatives moved, right? And just to be clear, this has become neutral now. It's no longer red. So we have 2 positives, but they've now spread out a little bit, right? So what's the charge of the entire 2 can situation we have here now? It is positive, right? It's still positive, because if you count all the positives and all the negatives, you're going to have 2 extra positives. So the whole thing is net positive. But it's a little bit more dispersed now. So that's step 2. And in step 3, we're going to take these cans and break them apart. So step 2 here, we're taking this can and moving it away. And once we move it away, they become 2 separate entities. But notice, because we did it very quickly, the charges have stayed in each can. So this one still has 1 plus and 1 plus. So this is net positive. And this is net positive. There are 4 primary ways a material can be charged: friction, conduction, induction, or grounding. Friction requires the rubbing of 2 materials. Conduction requires 2 materials to touch. Induction means the 2 materials do not touch. And grounding means that one of the materials touches the ground. In this situation, it's pretty obvious. We had 2 cans touch, so this would be conduction. This problem is very similar to the last problem. The only difference is, instead of having a positive can, we have a negative can. So I have the same setup here. We have all neutral cans here. So in this situation, it'd be like 2 neutral cans coming together and touching, and then being pulled apart. So really nothing's changed. But we want this one to be negative this time. So I'm going to add some negatives here. I'm going to put in 4, It doesn't really matter as long as there's more negatives than positives. But the reason I put in 4 is I want you to show you how they spread out. So they've spread completely as far as they can get. And on this one, this can B is neutral. And then when they come together, this one is carrying its negatives, right? I'm going to erase here. So if you're following, make sure to use maybe pencil. But take a look. Let's say, I'm just going to get rid of this wall just so you can see it. They've come together, and when the cans come together, they're made of metal, so they're conductors, so they become one big can. And now, what do you think is going to happen to these two negative charges? They're going to go to the four corners. They're going to stay in the four corners of the entire AB can now. So they're going to move. And remember, the negative electrons can move. The positive protons cannot move. But these electrons can move. They're really small, and they're in a conductor, which allows electrons to move. So they've totally spread as far away as they can get. Now this entire material right here is negative, the two cans together. Then we separate the cans, basically cut really quickly, pull them apart, and we're left with the two, and they'd probably spread out as far as they can get in the can that they're in. And so now we have two cans that are negative. And once again, the means of charging for this was through conduction.